Step 3. Defining the variables. In the next section, you see a list of all variables within the selected scenario. Nosco consists of variables and interrelations between those variables. Variables have interrelations to one or many other variables, either by addressing those variables or by being addressed through those variables. This is what we call direct effects. Beyond that, variables can also have interrelations to interrelations between other variables. This is what we call moderating effects. So, let's define a new variable by selecting New from the action pop-up menu at the bottom. First, specify the name of the variable and describe it in the according field. There is an autocomplete function which shows you as you type which variables have already been defined by other users in previous scenarios. Then, define whether the variable can be actively changed by the user, or if it is an external variable which cannot be actively influenced. An example for a changeable variable is the number of staff people within a company. An example of an unchangeable variable would be the conversion rate between two currencies or the unemployment rate of a state. The next step is to specify the unit or the actual value of the variable, as well as the maximum, minimum, and when needed, a value limitation. For example, a variable EUR stocks would have an actual value of 3,587.06 in a dimension of points. In case where there is no specific value available, start with 100% as the starting value. An example for such a variable would be the communication mistake by a member of the board. Then, specify the desired deviation variance. To do so, research the internet for the range the specified value has changed over the last 3 years. Calculate the arithmetic mean and the maximum of deviation from the mean. Use 1/3 of the value for your range value and type it into Nosco. In case there are no such values available on the internet, estimate the variation value. It is not important to emphasize precision of all data from the beginning. Nosco represents a systematic approach, where not all the details of the single variable values are known, but the accuracy of the interrelations between those variables. The specification of a variance is something unique to Nosco. It enables a uniform level of all the variables within the scenario and offers clarity of perception, which would not exist if we used quantitative values with different units and dimensions. On the right-hand side, you can see several grayish fields. These fields indicate the mean average values, deriving from the collective users of Nosco. These users have made their own considerations about this specific variable with which you are working. This data represents the swarm intelligence, which build an ideal basis in order to find the right values for the corresponding input specifications. Save the variable. In the next step, specify all the other relevant variables in the actual context, just like it was indicated in the first variable. On the right-hand side, you can see a list of all possible combinations between the specified variables. The Action pop-up menu offers special functions which allow you to set up a valid and consistent variable list very quickly. For example, if you have a list of 10 variables available and you have applied all these variables into the Nosco portal, you may wonder if there are additional relevant variables of which you are not aware of at the moment. It is clear that a scenario will deliver reasonable results if you have implemented all relevant variables in advance. As soon as you overlook some relevant specifications, the scenario will not deliver the desired results. To help mitigate the exclusion of overlooked variables and to assist in finding additional variables, Nosco offers 3 options. The first possibility is to select the Read Publication function in the Action pop-up menu. In the next page, you can open a file in the TXT format, which will be automatically analyzed by Nosco via semantic analysis. With this function, you see other possible variables not yet considered that might be of relevance for the actual scenario. If necessary, describe further impacts by defining a start and an end variable, as well as the corresponding semantic relation with the resulting impulse declaration. This information is used for variance and interrelation analysis, making it easier to configure further scenarios on the basis of a growing, self-learning knowledge network. The second possibility is to select the web crawling function in the Action pop-up menu and search the internet via the www button for contextually affiliated items. You can repeat this process by combining several variables, researching deeper into the internet. The third possibility is to select the Swarm Intelligence function in the Action pop-up menu. Declare the total number of variables that should be generated for the actual scenario. Nosco will search for possible affiliated variables in all scenarios, which have already been defined by other users. According to their respective statistical representation, Nosco will propose the most relevant ones and add them to the already existing list of variables. According to the Swarm Intelligence information, Nosco automatically generates a fully relevant scenario.